actually honored to be here. So what I thought I will take this time to introduce you to some of the recent results which I have been working on. So I work in the broad field of AI, and one of the focus in the last few years have been the so-called unsupervised learning. So if this doesn't make sense to any of you, I'm sure I'll try to make some sense, at least the definition wise, in the next few minutes. So my research has largely been foundational. However, we also venture into some applied domains, and I'll try to illustrate my talk with some examples. So as I was asked that I should keep the talk at a general level, so hence I'll take the first 5 minutes to introduce the field, if I may say so. So one of the foundational questions in AI is this question: can machines think? Now close your eyes and ponder over this question. It brings together philosophy, thinking. It brings the machines its engineering, and thinking is also a consciousness related issue. Also brings neurobiology also in play. So after industrial revolution, as machines have been built, these questions have been plaguing thinkers, engineers, scientists across different fields. So this was the state of the art in early 1900s. The top scientists of the day in their conferences and workshops have been debating these things. So then came an interesting breakthrough. Doesn't work? Okay, sorry. Mac and this Hollywood. No, I was joking. So this imitation game, and the founding father, Alan Turing. So he had this amazing, interesting insight in this paper, Computing Machinery and Intelligence. It came out in a philosophy journal called Minds. So he chucked all these questions aside and said, look, that's not the way you're going to make progress, because there are so many intractable problems here. We don't understand neurobiology, we have not enough, our understanding consciousness is at best very primitive. We won't be able to think like how do machines think. I don't think we'll make progress. So he said, let's take a simple thing. So apparently in Britain, 1700s, there was this. See, we have these small fairs, right, where people come and this in the small fairs there is this game that there is a room. In the room, there is a person, and outside you can only exchange notes. And the person from outside will ask you a question, and the answer will come, and from that you will figure out whether it is a male or a female. And the person will try to fool you, saying that no, a male person will try to fool you as a female, and a female person fool you as a male. This is an imitation game, right? So you took that model and said, look, suppose there are 2 rooms. In one room, there is a human being. In another room, you put another machine. I'm going to pass questions to both of you. I do not know which room the machine or the human being is this. Right? Now, if the interrogator, the person who's passing the questions, cannot figure out which is human and which is machine, I will say machine is intelligent. That is the thing he has posed. Right? And that has defined the field so far. So A and B and C are the same cartoon I have drawn. So this is the thinking which is pervading today. That is why you will see I talk to Siri, right? And Siri is considered AI, right? You see your latest computer vision research, that's termed as AI. Why? Can you mimic human sight? Can you mimic human hearing? So mimicking human beings, and that is what the current state of the art is, and thanks to him, and that is where we are. And he himself postulated that, the amazing foresight that he had, that maybe 50 years from now, somebody will break this test. So this is called the Turing Test. And as of today, okay, it's not there yet, but today I think most of us do not know, often you call up many airlines, see you're talking to a phone actually, talking to a computer program. So this is there. But still still a lot of distance to go. So that being said, in this field of AI, so there are many interesting things that goes on. So we hear AI everywhere, a lot of applications and all that. So I would like to illustrate one of the products which we have launched through a video instead of me talking. That will give you some, and I'll make some comments after that. It's a short video.
65% of the 1.3 billion population lives in rural areas. Rural India has only one radiologist for every million Indians. COVID-19 has rattled our health infrastructure like never before. RT-PCR tests are often delayed in rural India. X-rays can be a faster way to identify COVID and plan early intervention. Introducing X-Ray Setu, quick chest X-ray interpretation for doctors via WhatsApp. Developed by the AI researchers from ArtPark, Niramai Health and IISc. X-Ray Setu, bridging the gap between accessibility and technology. How does it work? Step 1. A doctor clicks the picture of X-ray image using her or his mobile phone. Step 2. The doctor then shares this picture on WhatsApp with X-Ray Setu at 804-616-3838. Step 3. X-Ray Setu AI service automatically generates a provisional report within minutes. Step 4. The generated report has probability of COVID, pneumonia, markings of the lung image, and markers to other abnormalities. The doctor gets the report within minutes on WhatsApp. X-Ray Setu helps our COVID warriors in their fight against COVID. Key highlights. 300 plus doctors have trusted X-Ray Setu over the last 10 months. X-Ray Setu is accessible and easy to use. No apps to download. It works with both analog and digital X-ray machines. It also works on low-resolution images. It marks 15 lung abnormalities, including COVID. The best protection is early detection. Here is what doctors say about X-Ray Setu. X-Ray Setu, built for doctors, easy and quick X-ray report. Try the free beta. Check out.
Yeah, so that's one. So that was built through the so-called AI technology. So one of the things, as you can see, this was meant to bridge the gap between the radiologist and radiographers. Radiographer is the one who take the X-rays. Radiologist is the one who the city will tell you what it is. So now radiographers, as you can imagine, are in the villages or the tier 2 cities, and radiologists are sitting in urban areas. So this is the thing to bridge that gap. That's a Setu. And now we were really humbled to see our uptake. This is a snapshot in one of the months. It was launched during COVID. As you can see, it has reached the heartland of India. And these are not from cities. These points where we got this usage. These are actually from, we can show you the pin codes and things they have written from villages and things like that. So as you can see, AI can, definitely this one very small thing we did during COVID. By small thing, I mean, if as a nation we can do much more. Now, this shows the power of AI. But then it brings to other more interesting and difficult questions, I say. So one of the things is that, okay, what did you use? Where is your AI? So the thing is, there are so-called quote-unquote deep learning architectures. We'll not talk what deep learning is, maybe because of lack of time. But let us say probably all of you know deep learning is, you can see in the press and things like that. So deep learning. So there are certain deep learning architectures which have been available. So we repurposed some of them, used some other machine learning paradigms, and developed our models, whatever that is, and that was deployed. Now, the interesting fact is that these all boxes are essentially models. Interesting fact is that they have large number of parameters. Now, you don't have to be really, let us say, a cutting-edge statistician. Even a simple a person with elementary knowledge of, let's say, a master's level knowledge of data analysis will tell you that more parameters, you need more data. And that we don't have. So there's 1 million plus parameters, we don't have that much data. So there lies one interesting challenge. So now, this one more other important challenge we would like to figure, we want to make a comment about this. So there's a very interesting paper came out last year. These are names of some deep learning architectures. and these are papers published on this architecture, various modifications and various applications. Now, one of the persons, what they did was they measured the energy consumption of just by training one of these in one of the cycles. Just take the model and train. And often those of you have running these deep learning models, you hear this word GPUs. GPUs are powerful computing paradigms, right? Now, energy consumption is something like this, right? Then if I'm consuming energy, I can also put a carbon footprint to it. India may be a little difficult, but in many places in the US you can do that. So it's the carbon footprint, right? Of course, most of things runs in corporate, in Amazon cloud and all that. There is an approximate cost. But I think let's focus on this now. Let me show you one interesting fact. Now, see, these facts don't mean much unless you have something to compare against. Here's a comparison. So essentially, training these transformer models, right? Actually, it is just one iteration is equivalent to a carbon footprint of a lifetime of a car, 5 times that. So now this is just one paper. This is one iteration. To get a paper out, you have to do 10 to 15 iterations, and there are many. And look at the citations these things have. So look at the carbon footprint of these things. So obviously there is a lot of things going on here, and those of you know, this person won the Turing Award for AI. So this has led people to think: is this the revolution we were thinking AI will bring? And according to him, no, this is not the AI revolution. It cannot be so environment unfriendly. It cannot require so much of data. There are more. So according to him, the revolution will not be supervised. By supervised, I mean the traditional ways of AI things supervised. That is, here is a picture. This is our cat. This is a picture of this is a dog, right? So I give you the images and I give you those labels, and then you learn something, and you build a machine. And machine next input to the machine is you take an image and say it's a cat or a dog. So the supervised learning stuff has obviously gone a great distance, as you can also, I personally have seen Extra is one of the great examples of that. But then that is probably still not the AI revolution. It says it has to be unsupervised. So now, since the lack of time, I will not belabor some of these points, is already written there. But the need of the hour seems to be that modeling paradigms which can learn without supervision. That is, I just give you data, I don't tell you these are cats or dogs. Now figure out what is to be done. Number one. Number two is, it requires rigorous formalism so that you don't have to spend, that kind of energy to train this. Energy just, So that brings us to the context of my personal research. Now, unsupervised learning, right? So now, to illustrate the point, suppose I take a fruit and measure 2 parameters. To make it up, you just measure maybe the length and the color. And color, you can put some number, right? So maybe here's an apples, and here is something else, maybe guava or something. So here and they just stack up like this. Just scatter plot shows like this. I have colored them just to say, these are apples and guava. So how do you build a machine? Okay, very simple. Draw a line. These are the lines are apple. These are lines is guava. That's the standard machinery which we are used to. Now let's do one simple experiment. I just remove the apples and oranges information. Now figure out what is happening. Now we are lost. So this is a very simple problem, and all of you, those who are users of AI, often have used the word k-means algorithm. Maybe you have used this clustering. Now unfortunately, you don't even know how to solve that. That's the open problem. So we have made some progress in how many clusters, but this is not the day to talk about. So interestingly, SODA is a conference in computer algorithms, theory conference. So machine learning problems, to make progress, we need, this has to, even standard algorithmic theory has to progress much further. But anyway, this is not the point of today's lecture. So I'm going to talk to you about 3 hard problems, again, which were banging my head for the last few years. So as we said, what are the goals of unsupervised learning, right? In supervised learning, the goal is very clear. I give you an image, it will tell me the right label. Here I don't have a label. I just give you this blue circles. So what do I do? What's the label? So now, so that means, so how should I pose the question? So so basically one of the questions is, then maybe you should think of like this, that can you recover a model where data must come from the model? Can you recover the model? How many samples do you need, and etc., right? So this brings us some of these questions like model recovery. So for example, data comes from a, from a model which you know, and can your algorithm recover the model from finite number of samples? And then you can ask what are the minimum numbers of sample complexity, and then model complexity, right? Suppose somebody gives you data and say, look, there are two models which model this, so which model should I pick? So model complexity measures, right? So these are some of the things we thought we'll illustrate. I'll not illustrate the second point, but probably we'll talk about model recovery. So then very quickly, I'm going to touch upon the first point where we say geometry meets topic models. So basically it's a compendium of these three papers. So maybe what I will do is I will just tell you what topic models are, and we'll develop a new problem, not the answer. So we'll talk about that. So what are topic models? So suppose you look at this first column. So I say that this is a document, this is the run, inning, hit, season, game. What can the document be? I don't tell you anything. No noun, no verb, no phrase, right? Suppose that this I said this document, computer, software system, Microsoft company, right? So possibly you will agree that maybe this document is about sport, this document is cooking, this is healthcare, right? So this is, can you bring this intuition now? Can you find these topics? The topics are also called themes. So now I just give a bunch of documents, can you figure out these themes, right? So this has led to a very interesting line of work. So now let's assume that I have a corpus, this set of documents, and I stack the corpus up in a matrix where each row is the word count of as it appears in each of the documents, right? So now the problem is this, that our topic is basically you can think about a probability distribution over words, and let's say M is my topic matrix. There are k topics. Now we generate data from this. That's what you see as A. Now from A, can you derive M? So the hard problem is that the whole world is trying to do this. That from A I have to get M, and one of the way to do is that what you do is maximize the likelihood. This is the best fit approach. Now what is happening is very simple to say best fit approach is NP hard. NP hard is another fancy way of saying I don't know how to solve it. So obviously we can't make progress like that. That's the field has been. So we said the game has to be changed. I'm sorry I'm taking this time. So maybe that's what the point I wanted to make. So we said maybe best fit approach may not be the right one. Maybe you can think about like this, that suppose there is there is a model, there is a promise of a model. Can you recover that model? And that doesn't have to be best fit, right? And so there we had made some progress. So this algo A is what we were talking about. So we have developed an algorithm which has some sample complexity, etc. But I think I'm hopelessly out of time. So with that, with apologies, I stop my talk. Thank you.
Thank you very much. Thank you. I don't understand that in this context, but however, if in the context of X-ray Setu, can you tell me what is the carbon footprint for each image analysis?
No, we have to measure that. We have to measure that. So I can tell you how this. So there's a paper out. You can read this paper and you can see how they have measured it. This is also getting into controversies. Obviously, corporates will not like this. The idea is they're saying there are two columns. First is environmentally unfriendly because of this. Second is you see this thing runs on cloud. So very soon it will go out of academia's hands. So anyway, so what they have done is, what I do is I take my electricity bill that I can measure. If you have electricity bill, there are other data to say that this percent of your electricity is generated from fossil fuels, this comes from renewables, all that. So those fractions are available in the United States. I do not know here. So but there are procedures laid down in that paper. So India would love to do this kind of experiments. No, these are PhD students. See, this is no private company will do, and Google immediately came back with a huge pushback. You can imagine why.
Excellent talk. Two short questions.
Sure.
One was a clarification. Unsupervised need to be only human supervised, or the above line algorithm can itself supervise?
Unsupervised means, see, okay, I think I should have made it clear. Supervised learning definition is as follows. You give me an image, and you say this is dog or cat. You give me this label, right? Now at this point, I don't tell you that. The dog cat labels are not available.
Okay. And the second one is, are there limitations for X-ray set 2?
Oh, okay, plenty of limitations. Now the problem is there are good news and a bad news. The good news is COVID has gone away.
Yeah.
Okay, we can live with it, right? That's the good news.
Okay.
It is not as dangerous as what it was. Bad news is we have nothing to do now. So electricity is shut down. So, but this has opened my eyes to the following. I firmly believe now, this is an example, that modern day healthcare will not be you have to go to a hospital and do things. This is an example. And that is the line we want to follow. And so, sir, a lot more needs to be done. We are desperately sort of funding, we are desperately sort of positioning. But here, if you can support us, we will be great too. Right.
Thank
Sure, please.
In the unsupervised learning, would you give me a class of models or would you not even give me that?
I give you data.
You give me data, but
And do whatever you want.
no, but again, I'm trying to simplify the problem. You can give me a class of models and without telling me, the details of that model, but you can tell me that this is data from a class of animals. This is data from a class of plants. Can you identify the plant or the animal? So that's what I mean by a class of models. That makes life a little easier, but
So maybe some context is definitely available. For example, the topic modeling problem, right? I give you a corpus of Anandabajar Patrika. Okay, now I ask you what are the topics. So that much context is available. Now, what class of models you pick, like by model I mean, so there is also this, maybe I think you're not going there, but let me just say this. So there's something called parametric model. That is, I say this model has come from a Gaussian. But I'll not tell you the Gaussian's parameters. So that's one line of approach. And the best fit approach is exactly trying to do that. And when it comes to real life problems, it fails horribly. Because as you can show, it doesn't take much to say this NP hard. And so that's the requirement for, I hope that answers.
Yeah, I think maybe we'll postpone it to lunch.
Sure. Thank you. Apologies again for not able to finish that off.